Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.20. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always zero. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. Now move towards the problem. Exercise problem number 2.20. Find the value of current I1 in given below figure. This is the circuit diagram of given problem. We have to find the value of current I1 inside this circuit. So without wasting time, let's proceed towards the solution. In this circuit, if we observe, the only information that is provided is in the form of currents, and it is asked to calculate the value of current as well. So we will use Kirchoff's current law for the solution of this problem because it is purely based on currents. This circuit have multiple nodes, but our concerning nodes will be these three nodes. We will start from this node. On this node, all three currents are entering. One is Ix, other one is I1, and third one is 6 milliampere current. So write Kirchoff's current law equation for this node. 6 milliampere plus Ix plus I1 is equal to 0. In this equation we have two variables, so we cannot further solve this equation. So for right now we will leave it as it is and label this equation as equation A. Move to the next node. On this node we will apply Kirchoff's current law, but before that we have to identify the direction as well as the magnitude of current through this branch. Right now in question, no parameter of current as well as its direction for this branch is specified. So we will assume the direction of current is downward moving towards this node and the label of current is Iy. Now apply Kirchoff's current law on this node. On this node, one current is entering, that is Iy, while two currents are leaving, both are of 6 milliampere and both currents will be taken with minus sign. So from this equation we can calculate the value of current Iy by simply adding these currents together and placing them on the other hand side of equal. So the value of Iy will become 12 milliampere. Now we will apply Kirchoff's current law on this node. On this node, two currents are entering, one is 2Ix and other one is 4 milliampere and one current is leaving, that is Iy. So write Kirchoff's current law equation for this particular node. 2Ix and 4 milliampere are entering currents while Iy is leaving current. And we know the value of current Iy, that is 12 milliampere. So enter the value of current Iy inside this equation. This equation will become 2Ix plus 4 milliampere minus 12 milliampere is equal to 0. Now subtract 4 milliampere from 12 milliampere. It will become minus 8 milliampere because the larger value have minus sign along with it. And place that minus 8 milliampere on the other hand side of equal to make it positive 8 milliampere. Divide on both sides with 2 to calculate the value of Ix. That will become Ix is equal to 4 milliampere. Now we have calculated the value of current Ix. We can place the value of Ix inside this equation A to calculate the value of current I1. So place the value of Ix inside this equation. Ix is replaced with 4 milliampere. Now inside this equation only one variable exists, that is I1, and we are interested to calculate the value of I1. Add 4 milliampere and 6 milliampere together, it will become 10 milliampere, and place this 10 milliampere on the other hand side of equal to calculate the value of current I1. That will become minus 10 milliampere. So the value of current I1 inside this circuit is minus 10 milliampere. So this was exercise problem number 2.20. Thank you. See you again in next video.